The question we are solving now belongs to test series 7. It is of control system subject. In specific, it belongs to root locus of the control systems. The question is numbered 11. As per the question, the open loop transfer function of a unity negative feedback control system is given as k divided by s plus 3 multiplied by s square plus 5. There are two statements given as related to the root locus of the control system. The statement 1 is that the asymptotes meet on real axis at -1, and statement 2 is that the root locus meets the imaginary axis at plus or minus 2j. We have to pick the correct option out of these two as related to the we have to pick the correct option as related to the correctness of the statements 1 and 2. We see that for the given g of s into h of s, the poles are located at -3 and plus or minus root 5j. The intersection of the asymptotes on real axis is given as sigma p minus sigma z divided by np minus nz, where sigma p is the sum of the poles, sigma z is the sum of zeros, np is the number of poles, and nz is the number of zeros. On simplification, this becomes -3 plus root 5j minus root 5j minus 0 divided by 3 minus 0, which is equal to 1. Therefore, asymptote meet on the real axis at -1. So, statement 1 is correct. We can obtain the intersection of the root locus with imaginary axis by Routh-Hurwitz analysis. So, the characteristic equation can be obtained from 1 plus g of s into h of s is equal to 0. From this, we can write that characteristic equation is s cube plus 3s square plus 5s plus k plus 15 equal to 0. The Routh array can be formulated as shown. In this, the entries in the first two rows are 1, 3, 5 and k plus 15. Therefore, by filling the Routh array, we can see that the entry at this point is 15 minus k minus 15 divided by 3, which is equal to minus k by 3, and entry at this point is k plus 15. Therefore, we see that the given for the given control system, the root locus intersects with imaginary axis for k equal to minus 15 or k is equal to 0. But from the given data, k is greater than 0. Therefore, root locus doesn't intersect with imaginary axis. That implies the statement 2 is not correct. Therefore, out of the given statements, statement 1 is correct and statement 2 is not correct. Therefore, the correct option is A.